Today we'll be talking about storing keys with associated values in hash map. The last of our common collection is the hash map. The type hash map KV stores a mapping of the keys of type K to values of type V using a hashing function which determine how it places these keys and values into memory. Many programming languages support this kind of data structure, but they often use a different names such as hash, map, object, hash table, dictionary, or associated array. Just to name a few, hash map are useful when you want to look up data not by using an index as you can with vectors, but by using a key that can be of any type. For example, in a game, you could keep track of each team's score in a hash map in which each key is a team's name and the values are each team's score. Given a team, you can retrieve its score. Where we will go over the basic API of hash maps in this section, but many more goodies are hiding in the functions definition of hash map by the standard library. As always, check the standard library documentation for more information. Creating a new hash map. One way to create an hash map is using the new and adding elements with insert. In listing 8-20, we are keeping track of the score of two items whose names are blue and yellow. The blue team starts with 10 points and the yellow team starts with 50. Note that we need to first use the hash map from the collection portion of the standard library of our three common collection. The this one is the least often used, so it's not included in the feature brought it into scope automatically in the prelude. Hash map also have less support from the standard library. There is no built-in macro to construct them. For example, just like vectors, hash map store the data on the heap. This hash map has keys of type string and values of type i32. Like vectors, hash map are homogeneous. All of the keys must have the same types as of each other, and all of the values must have the same type. Accessing values in a hash map, we can get a value out of the hash map by providing its key to the get method as shown in listing 8-21. Here score will have the value that's associated with the blue team, and the result will be 10. The get method returns an optional value. If there is no value for that key in the hash map, get will return none. This program handles the option by calling copy to get an option i32 rather than an option i32, then unwrap or to set score to 0. If score doesn't have an entry for the key, we can iterate over each key value pair in a hash map in similar manner as we do with the vectors using a for loop. Let mute score equal to hash map of new scores dot insert. Okay, you can use a for loop for hash map, looping over a hash map. Hash maps and ownership for types that implement the copy trait like i32, the values are copied into the hash map. For own values like string, the values will be moved and the hash map will be the owner of those values as demonstrated in listing 8-22. We aren't able to use the variables field name and field value after they have been moved into the hash map with the call to insert. If we insert references to the values into the hash map, the values won't be moved into the hash map. The values that the references point to must be valid for at least as long as the hash map is valid. We will talk about these issues in the validating references with lifetime section in chapter 10. Updating a hash map. Although the number of key and value pairs is growable, each unique key can only have one value associated with it at a time, but not vice versa. For example, both the blue team and yellow team could have 10 values stored in the scores hash map. When you change the data in a hash map, you have to decide how to handle the case when a key already has a value assigned. You could replace the old value with the new value, completely disregarding the old value. You could keep the old value and ignore the new value, only adding the new value if the key doesn't already have a value, or you could combine the old value and the new value. Let's look at how to do each of this. Overriding a value. If we insert a key and a value into a hash map, then inserting the same key with a different value where the value associated with that key will be replaced. Even though the code in listing 8-23 called insert twice, the hash map will only contain one key value because we are inserting the value for the blue team's key both times. Okay. This code will print blue 30, blue 25. The original value of 10 has been overridden. Adding a key and value only if a key isn't present. It's common to check whether a particular key already exists in the hash map with a value. Then take the following actions. If the key does exist in the hash map, the existing value should remain the way it is. If the key doesn't exist, insert it and a value for it. Hash map must have a special API for this called entry that takes the key you want to check as a parameter. The return value of the entry method is an enum called entry that represents a value that might or might not exist. Let's say we want to check whether the key for the yellow team has a value associated with it. If it doesn't, we want to insert the value 50, and the same for the blue team using the entry API. The code looks like listing 8-24. The or underscore insert method on entry is defined to return a mutable reference to the value for the corresponding entry key if that key exists, and if not, inserts the parameter as the new value for this key uh, for this key and returns a mutable reference to the new value. This technique is much clearer than writing the logic ourselves. In addition, plays more nicely with the borrow checker. It will print yellow equal to 25 but blue equal to 10. Updating a value based on the old value. Another common use case for hashmap is to look up a key value and then update it based on the old value. For instance, listing 8-25 shows code that counts how many times each word appears in some text. We use a hash map with the words as key and increment the values to keep track of how many times we have seen that word. If it's the first time we have seen a word, we will insert the value 0. This code will print world 2, hello 1, wonderful 1. Use a hash map with the words as key and increments the value to keep track of how many times we have seen. If it's the first time we have seen a word, we will first insert the value of 0. You might see key value pairs printed in a different order. Recall accessing a values in hash map section that iterating over hash map happens in arbitrary order. The split white space method returns an iterator over subslices separated by white space of the value in text. The or underscore insert method returns a mutable reference to the value for the specified key. Here we store that mutable reference in the count variable, so in order to assign to that value we must first dereference count using the asterisk. The mutable reference goes out of the scope at the end of the for loop, so all these changes are safe and allowed by the borrowing rules. Hashing function by default. Hashmap uses a hashing function called sip hash that can provide resistance to denial of service attacks involving hash table. This is not the fastest hashing algorithm value, but the trade-off for better security that comes with the drop in performance is worth it. If you profile your code and find that the default hash function is too slow for your process, you can switch to another function by specifying a different hasher. A hasher is a type that implements the build hasher trait. We will talk about traits and how to implement them in chapter 10. You don't necessarily have to implement your own hasher from scratch. Scratch.io has libraries shared by other Rust users that provide hashers implementing many common hashing algorithms. Vector strings and hashmap will provide a large amount of functionality necessary in programs when you need to store, access, and modify data. Here are some exercises you should now be equipped to solve. Given a list of integer, use a vector and return the median. When sorted, the value in the middle position and mode the value that occurs most often. A hash map will be helpful here. Of the list, convert strings to pig Latin. The first consonant of each word is moved to the end of the word and eva is added, so first becomes erst. Words that start with a vowel have hey added to the end instead apple becomes apple hey. Keep in mind that the details about UTF-8 encoding using a hash map and vectors create a text interface to allow a user to add employee names to a department in a company. For example, add Sally to engineering or add Amir to sales. Then let user retrieve a list of all people in a department or all people in the company by department sorted alphabetically. The standard library API documentation describe methods that vector strings and hash maps have that will be helpful for this exercise. We are getting into more complex programs in which operations can fail. It's a perfect time to discuss error handling. We will do that next. Errors are a fact of life in software, so Rust has a number of features for handling situation in which something goes wrong. In many cases, Rust requires you to acknowledge the possibility of an error and take some action before your code will compile. This requirement makes your program more robust by ensuring that you will discover errors and handle them appropriately before you have deployed your code to production. Rust groups errors into two major categories: recoverable and unrecoverable error. For a recoverable error such as file not found error, we most likely want to report the problem to the user and retry the operation. Unrecoverable errors are always symptoms of bugs like trying to access a location beyond the end of an array, so we want to immediately stop the program. Most languages don't distinguish between these two kinds of errors and handle both in the same way using mechanisms such as exception. Rust doesn't have exception, instead it has the result type for recoverable errors and panic macros that stops execution when the program encounters an unrecoverable error. These chapters covers calling panic first, then talks about returning result values. Additionally, we will explore consideration when deciding whether to try to recover from an error or to stop execution. So yeah, that's it for today's video. Thank you for watching. See you in the next one. Bye.